So just to before you get all frightened here, what I'm going to show you, remember that effect size measures the difference between two sample means without considering sample size, and all it considers is the standard deviation. So when we have two groups, we have two standard deviations, right? So we have to somehow bring those standard deviations together and somewhat get an average of the two. So in order to calculate effect size, we need to first calculate something called pooled variance. You guys got the notes, but you weren't here, right? Okay. So this is the formula for pooled variance. It looks very scary, but basically you're going to take the degrees of freedom for group X and divide by the total degrees of freedom, multiply that by the variance of that first group, and then add the same for the second group, the degrees of freedom for that second group. And let's see. Let's do this, okay? I'm looking at 11A, the handout we just did, and go to problem number 2, the one with the 3 moons. Now, let's pretend that we're only comparing new moon and eclipse, okay? So this is a 2 sample or 2 independent groups t-test. So we're comparing new moon to eclipse, and we want to calculate the effect size for that particular problem. So if we consider new moon to be our X group, and eclipse to be our Y group, what is the degrees of freedom for X?
7?
7? Is there 8 total?
Yeah, there's 8.
Okay. And then if we take a look at both groups, okay, it's 7 and 7, right?
Yeah.
The degrees of freedom. So that'll be 14. And then we got to calculate the variance for that new moon group. So do any of you still have it in your L2? No? Okay, so go back and put those numbers in. And while you're at it, put the eclipse scores in another column.
Is that the mean? You're putting the mean, right? Or
No, what we need is the variance right here. S squared. Okay, so right now you have all the numbers on the list. Okay, now go back to stat. And then go to calculate. And then select one variable statistics. And then select your list, wherever it is. Go to calculate. And I have 0.74 for my SX. Do any of you see that there?
yes.
Yeah.
Okay,
Like
so
74.
remember it's squared, okay? That's gonna be the standard deviation squared of what we call the variance. Okay. So we'll leave that as it is. We'll keep moving along here. We're gonna add this to the Y group. So the degrees of freedom on Y were 7 over 14. They happen to be the same size. That doesn't always happen. And we're gonna multiply this by its variance. So we need to go back to one variable stats and look for that list.
One point two.
1.25, anybody else get that?
Yeah.
Okay, 1.25 squared. So now you just need to do the math. So make sure you follow your order of operations. You're calculating the exponents first and those in parentheses before you sum the two products. And that's not it. We're not even at effect size yet. That's just the pooled variance. Julie, does that look right? No? You lost?
No, yeah, a little. No, I'm not lost. I'm just. I have a question afterwards.
Okay.
Yeah.
Can anybody else confirm this one?
Yeah.
Okay. All right, so now we have our pooled variance. Basically, this is an average of the two standard deviations. And now we're going to take this and incorporate that into our, now we're going to calculate the pooled standard deviation. So at this point, we're going to take our variance and take the square root of it. All set? All right, so now we have a workable standard deviation that has taken into account both of the groups. And now the formula for Cohen's d is not too complicated. We're taking a look now at the actual difference between the two means. And then we're going to enter our standard deviation, our pooled standard deviation, in the denominator. So in the numerator, what you have is the mean for group 1 minus the mean for group 2. That's the first bracket there. And the second part there is 0. That's always going to be 0. Those are the theoretical means if they were exactly the same. So you're comparing the null difference versus the actual difference. So that really it's just the difference between the two means. So do you guys remember what the means were? New moon? 9.38 for which one? For new moon?
Yeah.
Okay, 9.38. And Teresa, do you have the other?
Yeah, 7.88.
7.88. Perfect. So then we just calculate that. So the difference between the two means. Divide that by your pooled standard deviation, and that should give you your effect size, 1.46, which would be a large effect size. All right, so good. Glad you asked because that's important. If you missed that class, then you missed that piece there. Julie, you had a question.
Yeah. So on the worksheet for 10A,
Mm-hmm.
for the first one, when let's say I put in the numbers because I know how to get this and that, and then the XSP from last semester, and I do this.
This is the pooled standard deviation?
Right.
What do you mean from last semester?
I have a worksheet from last semester, and for some reason
Yeah,
I have this one written down. So I was wondering if this is how we would get the effect